Hi everybody. This next section that we're going to be talking about is how to do trig function values given a calculator. So you will need a scientific or scientific would be good, a scientific calculator to be able to type these in. There's not a whole lot of work here for me to show you. So my best suggestion would be to follow along and try typing the same things into your calculator that I will be doing on mine to get the same decimals. And I'll point out a few things along the way that might be helpful for you to know. So for instance, this says use a calculator to find a decimal approximation for each. And again, like I said, there's not a whole lot for me to show on the screen here. And so you can do minutes and seconds on most any calculator, or if you would like to, you can change it to the degrees with decimals that we talked about back in the first video. So you could take the 12 minutes on this first one, the sine 38 degrees 12 minutes. If you take the 12 and divide by 60, you can turn it back into a decimal, which would be 0.2. And so this is really asking you what is sine of 38.2 degrees. So if you don't want to try to figure out how to do the degrees with minutes and seconds on your calculator, you can do that, switch it back to decimals. And then from that point, you just take it and type it in the calculator. I would do, on my particular calculator, I hit sine first and then 38.2. On your calculator, you might have to do 38.2 and then hit sine. It just kind of depends on what type of calculator you have. And make sure that you are in degree mode. So on the top part of your calculator, you'll either see a capital D or a DEG that will tell you that you're in degree mode. But if you type this in the calculator, this comes out to 0.6. And it doesn't say how many decimal places to go to here, but they usually ask for either 6 or 8. So I'm going to take it out several spots. So I'm going to go 618.408. So that's 6 spots or 6 decimal places. The same thing with secant, cosecant, and cotangent. I'm going to do it kind of the same basic way, except keep in mind most calculators don't have those buttons on them. There is not usually a secant, cosecant, or cotangent button. But I will take the 15 and divide it by 60, and that'll give me 0.25. And so this says to find what is secant of 13.25 degrees. Remember, secant is the reciprocal of cosine. And so I could actually type in 1 over cosine 13.25. There is a button on the calculator that looks like cosine with a little -1 out beside it. Do not use that. Do not use that here. So cosine with the little -1 is not the same thing as secant. So be careful on that. You'll actually want to literally type 1 divided by cosine of 13.25. And since secant, you might remember the range on secant is defined to be bigger than 1 or less than -1. So you should not get a decimal number between -1 and 1. And we don't. This comes out to be 1.0273. That's 4 decimal places. We'll go 2 more. 49 if I round it off. And then the third one, cosine, this is just -15 minutes. So we actually have 0 degrees in 15 minutes here. So the 15 is just like on part B. The 15 divided by 60 is still 0.25. So this is really asking what is cosine of -0.25. And so that one's pretty straightforward to type in. Just cosine of 0.25, but you got to have a negative on it. I actually have to put the negative. I have to do the 0.25 and then hit the negative number or hit the negative sign. And you'll get something really close to 1. You'll get 0.99999, something about like that, depending on how many decimal places you go out to. That's really close to 1 because you might remember in the previous section we talked about how cosine of 0 is exactly 1. So we're just a little bit off of 0. So that's why we end up with something really close to 1. So hopefully you can get those same decimals. We'll do several different things in the calculator. So hopefully that's pretty easy, and we'll get to the little next topic here. Now, I just told you that we don't want to use that -1 to do secant and cosecant. That is absolutely true. The little -1 power tells you that it is the inverse function. So you might remember some of this stuff from algebra, that if you do a function multiplied by its inverse, they should always come out to be 1. Kind of like in algebra, you did x to the first power times x to the negative first power. You would add your powers together to get x to the 0, which is the 1. And so another way to write that is that we could take a function f of x and apply its inverse to it. The inverse and the function actually would cancel each other off to give you the x that's left over on the inside. So if we apply that to a trig function, kind of like the one below that, sine inverse, or sine to the -1, sine inverse of sine of theta, the sine and the sine inverse would cancel each other off and give you just theta. The inverse function is the only way to separate a trig function from its angle or degree. We use the inverse function when we want to find the angle itself. So I'll kind of point that out in just a moment again. So here, this says find the value of theta between 0 and 90 that satisfies the statement. Here, if you're looking for the angle, like this theta right here, anytime you're looking for the theta, you have to use an inverse function. If you have an angle theta, then you don't use an inverse function. But if you're looking for the theta, you have to do the inverse. And so to do that, we would move the tangent to the other side by saying that theta is actually tangent inverse of 1.47396. And again, this is just a lot of typing things into the calculator. And so I'll go back to the calculator and type it in basically exactly the way it looks right there. I would do second tangent to get the tangent inverse. Some calculators also, if you do the second tangent, instead of a tangent to the -1, you will see an arc sitting in front of it. So it'll say ARC 10 out beside it. That's the same thing, and we'll talk about that a little bit later as well. And then I just type in the decimal number and hit enter. If you're in degree mode, then we'll get about 55 I'm going to go 2 decimals, 55.84 degrees. They usually want less decimals on the angles than they do on the other ones that we just did a while ago. So again, we're looking for this angle theta on sine theta. And so if I want to know what that theta is, I would do an inverse function on the other side. And so again, type it in basically the way it looks. Second sine of 0.27843196. And you'll get a theta of about 16.17 degrees. By the way, you can check these. If you then hit just the regular sine function of 16.17, you should get something really close to the answer that we have. If you do sine of 16.17, you get 0.2784, and then it goes a little bit off from there. But it's close enough to say, yeah, that's probably it. Now, usually the ones with secant, cosecant, and cotangent on them, those are the ones that I have people really get confused about. There is no secant inverse button on my calculator, just like there is no secant button on my calculator. And so to do this, we got to get it back to its reciprocal of cosine. To do that, I change secant to be cosine, and I can do that if I flip it over. So basically I'm flipping both sides. If you flip over secant, you get 1 over secant. That's where cosine comes from. If you flip over the other side, I get 1 divided by 2.7496222. And once I get it to this point, I have a cosine button and a cosine inverse button. So I could say that theta is now cosine inverse of, and then you type in 1 divided by that stuff in there. Some people make the mistake of doing the 1 divided by in the wrong spot. I'll show you what I mean by that in just a second. But I'll type this in the calculator first. So I'll do secant cosine, open a parentheses, and do 1 divided by 2.7496222. Close the parentheses, add, hit enter, and I'll get an angle of about 68.67 degrees. What some people do by mistake is they will type it in, let me see, I'll pick a different color, like this. Instead of cosine inverse of 1 divided by it, you'll see people type in 1 divided by cosine inverse of 2.74, da 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 da. They'll type it in with the cosine inverse on the bottom. You'll know that's wrong because if you try to type this in, this will give you an error. That's not the right way to do it. The reason is because cosine is defined between -1 and 1. You can't do a cosine inverse of a number that's bigger than 1 or less than -1. It has to be a decimal number. That's why we divide the 1 over the 2.7496222 to make sure we get a decimal between -1 and 1. So don't do this. Don't put the cosine inverse on the bottom of the fraction. Okay, so now we'll go on to 2.4, which is solving right triangles, and this has a few application word problems in it. So in these right triangles, this is the same triangle that we talked about in the last section where the angle matches the side across from it. The capital letters are your angles. The lowercase letters are your sides. The angle A is across from side A. Angle B is across from side B. Angle C is usually the 90-degree angle, and the hypotenuse is across from that would be side C. Also labeling it this way, we get our usual Pythagorean theorem of a squared plus b squared equals c squared. And remember to always look at the information in the given angle to determine which sides and which trig function, more importantly, that you'll want to use. So, for an example, in the right triangle, A equals 28 degrees, C is 17.4, can we find side A, side B, and angle B? I suggest, and I almost always do this, draw the triangle out. I like looking at the picture. If you don't need the picture, that's perfectly okay, but I like looking at an actual triangle when I'm trying to come up with what's going on here. So that's a pretty nice little triangle right there. Look at me go. So angle A would be over here. So side A is over here. Side C is across from the 90-degree angle. And then B is across from B. So this is the same triangle we had on the other page. I know A is 28 degrees. And I know side C, the hypotenuse, is 17.4. The easiest thing to find first is angle B, because all three angles in the triangle have to add up to 180. You could just do 180 minus 90 for angle C minus the 28 for angle A to get angle B. You may also notice that since it's in a right triangle, the angle A and the angle B have to be complements of each other, so you could just do 90 minus 28. That would give you the same thing. But you'll get 62 degrees for angle B. The sides come from what trig function do you want to use? I almost always go off the given information just to make sure it's rounded off the same way. So for instance, if I just go in alphabetical order, I'm going to solve for side A. Solving for side A, angle A is across from side A. So I'll need a trig function that has an across in it. And I have to use the hypotenuse, side C, because that's what I know. So I need a trig function that is an opposite with a hypotenuse. There are two of those. You can use sine, which is the opposite divided by the hypotenuse, or you could use cosecant, which is the hypotenuse divided by the opposite side. I never, ever, ever use secant, cosecant, or cotangent. I always use either sine, cosine, or tangent. And so I will do sine of an angle A would be the opposite over the hypotenuse. So I'm going to say that the sine of 28 degrees is the opposite is side A over the 17.4 for side C. Now, when you do this, to get the A by itself, all you want to do is multiply both sides by 17.4. So I would say that 17.4 times the sine of 28 degrees equals A. And at that point, we go back to the calculator. And we say 17.4 times sine of 28 degrees. That'll give me about 8. They have one decimal on everything, so I'll go one decimal as well. That gives me about 8.2. And I do the exact same thing for side B. Since I know angle B, I could use sine again and say the opposite over the hypotenuse, doing sine of B equals B over C. But, like I said, I tend to use the same info that they start me with. So I'm going to use the 28 degrees. Side B is the adjacent side to 28. So I'm going to use that cosine of A would be the adjacent over the hypotenuse. And say cosine of 28 degrees is B over 17.4. And do the same thing. Move the 17.4 to the left-hand side and say 17.4 times cosine of 28. That would be B. And then I go back to the calculator. Say 17.4 times the cosine of 28 degrees gives me about 15.4. One thing to kind of notice, and we'll talk more about this when we get to chapter 7 especially, the smaller angle always has the smaller side. So 28 degrees is the smallest angle, side A is the smallest side. B is the next smallest angle, so it has the next smallest side. But side B has to be less than side C, the hypotenuse. The hypotenuse will always be the largest side on a right triangle. Okay, let's try another one. On this right triangle, they're given two sides instead of an angle and a side. So it's a little bit more difficult, but not a whole lot. Again, I'm going to draw the same triangle we were just looking at. Hopefully kind of the same way. Yeah, that's not too bad. We have an angle A across from side A. We had an angle B across from side B. And an angle C across from the hypotenuse. What we know here is side A, that is, oops, probably do it in the same color. Side A is 76.4, and side B, that is 39.3. Automatically, I know without doing anything, I know C has to be the longest side, so C should be bigger than 76.4. How much bigger, I don't know. It doesn't even have to be a lot bigger, but it does have to be a little, bare minimum, a little bit bigger. So the easy thing to find here in this case is actually side C, because I can do the Pythagorean theorem. If you know two sides of a triangle, you can do the third by the Pythagorean theorem. So I'm going to do that a squared plus b squared equals c squared. And say this is 76, oh, I put the decimal in there too soon. 76.4 squared plus 39.3 squared equals c squared. We go back to the calculator and we'll do 76.4 squared plus 39.3 squared gives me 7,381.45. That would be c squared. And so at that point, you take the square root on both sides. And we'll say that c equals the square root of 7381.45. Gives me 85.9. Yeah, if you go one decimal place, 85.9. And that is your side C, doing the Pythagorean theorem. And so you can always do the Pythagorean theorem if you have two sides of a right triangle. As far as the angles go, I'm going to go in order and just solve for A first. If I know two sides, I have to do an inverse to come up with the angle. So here, for angle A, I know the opposite side and I know the adjacent side. So I need a trig function with the opposite and the adjacent. I'm going to use tangent. Tangent of angle A would be the opposite over the adjacent. In our problem, that would be 76.4 divided by 39.3. And just like what we did when we found the inverses a while ago, I want to get the angle. I'm looking for the angle. So anytime you're looking for the angle, you take the inverse function. And so I will say that angle A is actually tangent inverse of 76.4 divided by 39.3. Then I go back to the handy dandy calculator. For those of you who are Blue's Clues fans out there. I have a 2-year-old, so I don't have a choice. I have to be a Blue's Clues fan. So I have 76.4 divided by 39.3. Close that parenthesis off. Hit enter. And I will get that angle A is 62.8 if you go off the one decimal place. And then you could do another trig function to come up with angle B, but you don't have to, because remember, angle B would be 180 minus the 90-degree angle for angle C minus the angle we just came up with. That would be 27.2 degrees. If you did another trig function, that's okay. You could come up with a trig function. For instance, for angle B, I could do tangent again, just dividing them the other direction. Do 39.3 divided by 76.4, and doing that direction, you'll get 27.2. Okay, let's do another one kind of like that. Here, this is an angle and a side. We have angle B. This is in minutes and seconds, by the way, so that adds a little bit more of a layer of difficulty, but it's not too bad. You have an angle B, and you have a hypotenuse given to you. So here, that was supposed to be a straight line down. Maybe I can fix that. We just have to erase this little hangy over part here. There we go. A little bit better. So there's your angle A and your side A. Angle B, side B. Angle Z, side C. So we're given the hypotenuse is 0.6231. We're given angle B to be 39 degrees and 9 minutes. Remember, you can switch that to be decimals if you'd like. If you take the 9 and divide by 60, you'll get a decimal number of 0.15. So you can make this be 39.15 degrees. The thing about doing that, though, is your answers on the homework will want them to be in minutes and seconds because we're starting in minutes and seconds, but we'll switch them back as well. And so it says find angle A. That's the easy one to come up with. Notice it never asks you to find angle C, and that's because it's assuming that the 90-degree angle is angle C. So A would be just the 180 minus the 90 for angle C minus the 39.15. So if I did 180 minus 90 minus 39.15, I get 50.85. But again, you have to change that back to minutes and seconds. It might make kind of some sense that it's a 9-minute degree and there's 60 minutes in a degree. So I bet 0.85 is actually 51 minutes, the amount that it would take to get back up to 60. To check it though, all you gotta do is do 0.85 times 60 in your calculator, and that should be 51. So this is really 51 degrees and, sorry, not 51, 50 degrees and 51 minutes. And that is angle A. To come up with angles, side A and side B, I'll do kind of the same sort of thing that we did on the other one, the very first one that we did. Angle, I don't know angle A, so I'm going to use angle B here. And so for using angle B, and I want to solve for side A is the adjacent side to angle B. So I need an adjacent, and I know the hypotenuse, so I'm going to use cosine. I'm going to say cosine of B will be the adjacent over the hypotenuse. And so in our case, I'll have cosine, and I'm going to use the 39.15 degrees because I'll be typing it in the calculator anyway, and we won't have to switch it back to minutes and seconds. So the adjacent would be side A, which is what I'm looking for. The hypotenuse is the 0.6231. Again, I already know that A and B have to be smaller than C because the biggest side of a triangle, of a right triangle, is the hypotenuse. And so I'll multiply that across and get that 0.6231 times the cosine of 39.15 degrees. That would be side A, not angle A, side A. And then we go back to the calculator. 0.6231 times the cosine of 39.15 gives me A to be equal to 0.4832 if you go to 4 decimal places. That's side A. And then side B, again, now that we have two sides, you could actually do the Pythagorean theorem to come up with side B if you want to. The downside to that is I rounded off angle side A, the 0.4832. So using a rounded off number may not give you the exact value as nicely as the trig function would. So I'm going to do the trig function. So I'm going to use that sine b is the opposite over the hypotenuse. And so our sine of 39.15 would be, the opposite side would be b over the 0.6231, or the 0.6231. So if you multiply that to the left-hand side, I'll get 0.6231 times the sine of 39.15. That would have to be equal to b. And then we go back to the calculator. 0.6231 times the sine of 39.15 gives me 0.3934. And you might get that same thing if you did the Pythagorean theorem. But I can guarantee you'll get a better answer doing the trig function. And that's all the three missing pieces. So hopefully that's not too terrible. Notice again, the smaller angle should have the smallest side. The smallest angle is B of the three angles. So side B should be the smallest of the three sides, and it is. Okay, when we get into word problems, they're going to use terms like angle of elevation and angle of depression. Angle of elevation from a point X to a point Y that's above X, kind of like in this picture here, our angle of elevation would be rotating up like this. That would be your angle theta. It's an acute angle formed by the ray connecting X and Y together, and a horizontal one on the bottom. So we're rotating up. It's kind of like if you look out on the horizon and then you looked up, the amount that you looked up is your angle of elevation. Whereas if you looked out and then at the horizontal and looked down, you would have an angle of depression. So your angle of depression is measured going down. This is actually a positive angle as well. It kind of looks like we're rotating clockwise, so it should be negative, but it doesn't work like that. It's not a rotation in a positive or negative direction. It's just the amount of angle, how far you looked up or down, and that'll always be positive. And so the angle of depression is going below the horizontal instead of above. So for instance, we have from a window 30 feet above a street, the angle of elevation to the top of the building across the street is 50 degrees. The angle of depression to the base of the building is 20 degrees. Can you find the height of the building across the street? And so you might want a picture with this. And so there's a building. So here's your building. And depending on how good you draw, you can add all sorts of nice diagrams and stuff. So there's a building, and then there's another building across the street. I am not that great of an artist, so maybe there's another building going back here. You have the road going this way. You have a road going this way. Anyway, so we're going to go from the left building to the right building. So from a window 30 feet in the air, so there's a window. We'll say it's about right here. 30 feet in the air. The angle of elevation to the top of the building across the street is 50 degrees. So there's a horizontal that you're looking at. So if you look straight out this window to this building, you would have a horizontal line. And it's saying from that horizontal line up to the top of the building, that angle right there, and in fact, I'll erase some of the stuff that's inside the triangle now. That angle right there is 50 degrees. And it says the angle of depression to the base of the building is 20 degrees. So from that angle right there to the base of the building, going this direction, this way has to be 20 degrees. Again, I'll erase some of the stuff that's inside the triangles. So this is 20 degrees. How high is the building across the street? And so one key thing here is that you have to notice if this window is 30 feet up in the building, we're making a big assumption that the buildings are on level ground, and so that this side here of this triangle would also be 30. And so I need to find the distance in between the buildings first, because right now I have a triangle that's got the 20 degrees and the 30 on the side. I could do a trig function to say that the tangent of 20 degrees is the opposite, which is the 30, divided by the adjacent, which is, I don't know, I'm going to call that x. So I'm calling the horizontal side across the middle, that's my x. And so if you move the x over, you'll get x times tangent 20 equals 30, or x equals 30 divided by the tangent of 20 degrees. And we go to our calculator for that to see what that is. 30 divided by tangent of 20. And so you'll get that the buildings are about 82.4 feet across. Somewhere in that area. So then I have to figure out my other missing side. So my other missing side is this height here. I'll call that h. Because now I know what x is. X is 82.4, so I could do another tangent. And you'll notice tangent pops up a lot in word problems. I could do that tangent of 50 is the opposite, which is what I'm calling my h here, divided by the adjacent, which is the x. But the x is 82.4. And so if I move the x to the other side, I would say that x times tangent 50 equals h, but you can go ahead and put the x in there. 82.4 degrees times tangent 50 equals h. And then we go back to the calculator. 82.4 times tangent of 50 will give you an angle of about 98.2 feet. Now you do have to make sure you do not stop there. That h is only from the top of the building to the horizontal when you looked across. The building itself is that height plus the 30 feet you're already off the ground in the building. So the height of the building, I have to take the 98.2 and add it to the 30 that I originally was up in the building. So my building height across the street is 128.2 feet. So the next time you go on a vacation or go to a big city for some reason and you're in a hotel, you look out the window, you could figure out how tall the building is across the street just by doing some trig. I'm pretty sure no one would do that, but you could if you wanted to. Okay, how about this one? The length of the base of an isosceles triangle is 42.36. Each base angle is 38.12. Find the length of each of the two equal sides of the triangle. So what we have is an isosceles triangle. So an isosceles triangle, this is definitely where a picture will come into play very nicely. An isosceles triangle has a situation where two of the sides are the same. This says the length of the base is 42.36. So I'm going to say the 42.36 is the entire length across here. These left and right sides have to be the same, but I don't know what they are. But I do know that each angle on the bottom is 38.12. So this is 38.12. And this is 38.12. Now, we don't know a whole lot about how to work with isosceles triangles at the moment, but we know a lot about right triangles. So what I'm going to do is I'm going to take this isosceles triangle and I cut it right down the middle to make two right triangles, where now I have a base angle, the 38.12. I know that angle. They want to find the length of the side. So we're actually looking for what I'll call in this case side X. It's actually the hypotenuse, so you could call it C if you wanted to. And I have the side across the bottom. My base is 42/36, but that means I need to take half of that when I cut the triangle in half. So really, this side just right here on the left side right here, that would be 21/18. So this would be a situation where I need to do a cosine instead. For the 38.12, the 21/18 is the adjacent side. So I could do that the cosine of the 38.12 would be the adjacent side, 21.18, divided by the hypotenuse, the x in this case. So I would do x, move the x over to the left-hand side and say x times cosine 38.12 is 21.18, divide by the cosine, and so we'll get 21.18 divided by cosine 38.12. Go back to our calculator, type that in, and we'll get each side should have been about 26.92. Since it's isosceles, the two sides have to be the same, and so they're both 26.92. Okay, one last problem. Find the height of Mount Everest. Now, some of you might be thinking, why could you not just take out your phone and Google how tall Mount Everest is? And you could absolutely do that. But let's pretend like you didn't want to do that. So this is where we have two mountains, actually, at an altitude of 14,545 feet on a different mountain. A person takes a measurement to the peak of Mount Everest, and it's 27.0134 miles. And the elevation is 5.83 degrees from the peak of the mountain the person is standing on to the peak of Mount Everest. How tall is Mount Everest? So you really have two mountains. You have, say, a mountain like here, and then out in the distance, you see Mount Everest. And so there's a person standing here on the top of this mountain, and he looks, or she, depending on, I don't know, up to the top of this mountain off of a horizontal line. That's where your triangle comes from. And so if you want to get rid of the part of the mountain in the middle there we go. And maybe the mountain should be up to the top there, make it a little bit more realistic, I guess. So Everest is way in the background, and you're looking up at the top of this mountain. And I have a couple things. One, I know the hypotenuse, the angle of elevation going up, makes the hypotenuse go to the straight line to Mount Everest. That's at 27.0134 miles. And your angle is 5.83 degrees. We need to figure out the vertical side over on the right-hand side. We need to figure out this side, X. Now, there's one major flaw in this person's measurements, is the fact that they are 14,000 plus feet in the air, but they measured from themselves to the Mount Everest peak in miles. That's not good. So we have to change this to this 27.0134 miles needs to be turned into feet. And so, little stoichiometry for you. Every mile is 5,280 feet. So you'll have to multiply that by 5,280. So 27.0134 times 5280 gives you a massive number, 142,630.752 feet. So that's the real hypotenuse that we're going to need to use. Then we're missing the opposite side. We have the hypotenuse now. So I could say the sine of 5.83 is the opposite, the x, divided by the hypotenuse, which I'm going to use as the 142,630.752. Multiply that on the left-hand side and say that 142,630.752 times the sine of 5.83 degrees, that is x. Then we go to the calculator and see what we get. And I get x to be about 14,488 feet. That is not your answer. Keep that in mind. So the 14,488 is not the height of Mount Everest, because you were already 14,545 feet up in the air. So you have to then add that 14,545 feet that you were already up in the air when you measured that together to get a height of Mount Everest of probably a little more than 29,000 feet tall would be the height of Mount Everest. Or you go, how tall is Mount Everest?
According to Wikipedia, it's 29,029 feet.
So we're not too far off. If you heard that, Siri said it's 29,000, 28 feet, whatever. So we're not actually that far off. So pretty good measurements, in fact. But Mount Everest grows a little bit every year, so we'll eventually be right. Anyway, that's the end of chapter 2. Hopefully that all makes sense, and we'll start chapter 3 after this.